Hey everybody, it's your boy Albert. We're all going to be Feinstein coming at you from the lab. Just wanted to say, I hope we're all doing well at home, hoping we're finding ways to keep ourselves busy. Personally, I found myself last night reading a book on helium and I just couldn't put it down. Last week, we were talking about heat transfer and more specifically, the three ways in which heat is transferred. Today, we are going to be looking specifically at conduction through our Goldilocks lab. So let's get into it. All right, sixth graders, this is the Goldilocks and the Three Bears lab. Okay, and the question we are trying to answer is, how can it be that Goldilocks found 3 cups of the same liquid at 3 different temperatures? Now, we need to talk really quick about the audacity of Goldilocks. Okay, I'm assuming most of you have heard the story. But Goldilocks breaks in to these nice bears' home, sits down at their table, and starts eating their porridge. And she has the audacity to complain about the temperature of this porridge that she's trying to steal. Anyways, back to science. And we need to form a hypothesis as to how she could have eaten 3 cups of the same liquid and had them be 3 different temperatures. Okay? Test. We are going to compare the temperatures of water in 3 different vessels and see how the temperatures change over time. And we're going to gather our materials. Okay, I've already done so. We have a glass cup, a ceramic cup, a styrofoam cup. We have our graduated cylinder here to measure out 100 milliliters of water. And we have our trusty coffee pot of science, which is going to supply us with our hot water. And of course, we have our thermometer in order to test the temperature of the water. Okay? So what we're going to do is in the 3 vessels, we're going to fill them with 100 milliliters of hot water. Immediately, we're going to take the temperature of the 3 vessels, and they should be the same. Start the timer for 5 minutes. Every 5 minutes, check the temperature in degrees Celsius of your 3 vessels. And then we're going to record our data in the table on the next page. And the pre-knowledge questions. What is an insulator? An insulator is a material that reduces or prevents the transfer of heat. A conductor is a material through which heat can be transferred. Okay, that should ring a bit of a bell way back at the beginning of the year when we talked about the physical traits of matter. One of them was their conductivity, okay, and that's what this is talking about here, okay? Moving on to the next page, page 2 of your lab packet. Hey, which of these vessels will lose thermal energy the fastest / be the best conductor? And that's another prediction for you to make, okay? Which of these vessels will hold thermal energy the best / be the best insulator? Again, you need to make a prediction, or in other words, you need to form a hypothesis, okay? And then we will see how that turns out at the end of the lab. Of course, there are no right or wrong answers. And then here we have our table where we will be collecting our data. So why don't we go ahead. We are going to fill up our graduated cylinder with 100 milliliters of hot water. Check an eye level. I think we're good there. We're going to pour it in. $100 milliliters. Hey, we're good there. And finally, our glass vessel, 100 milliliters. Okay, now we need to measure the temperature of these. Okay, so our starting temperature should be 64.3 degrees Celsius. And we're going to start the timer. All right, so it's 0 minutes. We're at 64.3 degrees Celsius. All right, welcome back. It has been 5 minutes, so we need another temperature measurement from all 3 of our cups. And we will start with the styrofoam. And we are getting a reading of 58.2 degrees Celsius. 58.2 degrees Celsius. Okay, in our ceramic cup. And we're looking at 50.2 degrees Celsius. 50.2 degrees Celsius. And then finally in our glass cup, we have 54.1 degrees Celsius. 54.1 degrees Celsius. Start the timer up again. And while we wait, why don't we hear from our sponsors, from our good friends over at Hamilton Beach. For all of your science coffee maker needs, trust Hamilton Beach. All right, folks, we are back. It has been 5 more minutes, so we are at the 10-minute mark, which means we need 3 more measurements in the styrofoam. And we are looking at 52.5 degrees Celsius. 52.5 degrees Celsius. Okay, in the ceramic, we have 44.5 degrees Celsius. 44.5 degrees Celsius. And then in the glass, we're sitting at 47.9. 47.9 degrees Celsius. All right, we will be right back after another 5-minute break. All right, folks, we are officially at the 15-minute mark, which means time for more measurements. First up in the styrofoam cup, we have 48.1 degrees Celsius. 48.1 degrees Celsius. All right, in the ceramic cup, we have 40.3. 40.3. And in our glass cup, we have 43.7. 43.7.